All right, so inscribed angles. All right, so here our first bullet. Our first bullet, an inscribed angle is an angle with its vertex on, okay, on the circle. And that would be this point B here I just highlighted in red with two sides that are chords. Okay, a chord is any line that does not pass through the center, whose endpoints are on the edge of the circle. So that's why those are not diameters, because they do not pass through the center of the circle. The intercepted arc, which I'll highlight in blue here, is the arc that lies between the endpoints. So that's kind of a no-brainer. So the angle's endpoints are A and C, the intercepted arc, or the arc that goes with the angle. So let's talk about the angle would be down here, and that blue arc goes with that angle. The degree of the inscribed angle is always half the arc. Okay? So look at this red angle in the picture. It's ABC. It is half of the arc AC. Okay, it's half. So take that in mind. Let's go right to number one. The angle is always the smaller one. There's your angle. There's your arc. In this picture, the angle is just going to be 62 divided by 2. Half divided by 2. But number two, let's look at the reverse math. This is the angle now. The arc is what's bigger. This arc is 113 times 2. So you have to know when you're multiplying by 2 and dividing by 2. Remember, the arcs are the bigger ones. The arcs are always bigger than the angle in inscribed angles. So this would be 113 times 2. Okay, angle PQR. I want you to see this. Angle PQR has endpoints that are on a special spot. Its endpoints are a diameter. Anytime the endpoints of an angle are on a diameter, that is always a 90-degree angle. Always. When its endpoints are on a diameter, the diameter is in red. So that's a right triangle in there. How do we find BC? Be careful. It's not always just going to ask, so BC is over here. So be careful. How can we do that? Is one easy way is to recognize your half circles. That divides the circle into a half circle. We can find this. It's 94. It's twice as big as 47. So this red arc and this blue arc make a half circle. So to find that arc, I'm just taking 180 minus the 94 to get that red arc. So anytime you see half circles, remember, we can go back to our old skill of half circles. Okay, what's angle JKL? JKL is here. It has to be related to this arc, its endpoints. And I can find that arc. I can use the entire circle. That arc has to be what's left of the circle. If I take 360 minus 53 and 65, that bigger major arc is 242. And that angle has to be half of it. So that's 121. 242 divided by 2. Okay, so we have some intersecting, we have some triangles, a bunch of intersections here. So just take your time. Angle RST. RST is that red angle. It has to be half of this arc. I don't know that arc, but if you look carefully, I have 4 arcs that make this circle, and 2 of them are given. Or, I'm sorry, 3 of them are given, 75, 139, and 64. So if you take these 3 numbers plus that blue one, you have a whole circle. So you could find the blue one by subtracting the 3 you know. And I have 82. So that red angle is associated with that, and it is half. So let's look at RUT. RUT is this angle here. And I hope you see that it also uses the arc 82. So if they have the same arc, they're going to have the same measure. So angles with the same arc have the same measure. The algebra portion, okay, I'm not going to solve it for you. I'm just going to show you how to set it up. Okay, the angle is always half of the arc. So I can say the angle equals 158 divided by 2. So 158 divided by 2, 8x minus 9 equals 79. Add the 9, divide by 8, and you would be done there. You would get x equals 11 on that one. Okay, one more time. The arc or angle is half the arc. So on this one, I would say angle equals arc divided by 2. Okay. Now you could cut this in half or multiply by 2 to both sides. So if I multiply 2 to both sides, just to get rid of that 2, putting 67 times 2 in my calculator and get 134 equals 4x plus 58, because these 2 cancel out. And then you solve that and you'd have x. Take a look at number 9. This angle, you have to remember what I talked about earlier. Its angle is endpoints on a diameter. That means that angle equals 90. So the equation for this would be that angle equals 90. Any angle whose endpoints are on a diameter is a right angle. Okay, so on this one, I'm going to use the triangle. I think it'd be wise to zoom in here a little bit. I'm going to use the triangle on this one, okay? The triangle adds up to 180. So I have one angle plus a second angle plus an unknown third angle equals 180. And I can find this angle because its arc is 78, and it has to be half of 78. So 78 divided by 2, that missing angle in that triangle would be 39. And now I can solve it. Okay, let's keep going. I'm going to give you plenty of examples here. Okay, this angle is half of this arc, and I can find that arc if I consider that all 3 of these arcs, there's 1 and 2, and there's your third, add up to 360. So 360 minus 162 and minus 92 is 106. Remember, an inscribed angle, this red angle was half that, so 7x minus 10 equals half of 106. Honestly, can't I just take 106 and divide it by 2 and make it 53? I mean, that you can do that. 7x minus 10 equals 106 divided by 2. I can take 106 divided by 2 over there. Okay. All right, on this one, how can I find x is I'm going to use the arcs. So I have arc RS plus arc RQ is 120 plus my unknown arc equals 360. But I know this is 134 because I used my inscribed angle relationship and multiplied it by 2 to get that one. Now all arcs, 120 plus 134 plus the 5x plus 21 equals 360. And there's some examples of inscribed angles. Remember, inscribed angles are half of their arc. The arc is the bigger one.